Good evening, everyone. I am Aruvi Sharma, the student coordinator, and it is my pleasure to introduce Mr. Satyajit Azad as today's speaker in Generative AI Summer Internship 2024. He has completed his MBA from IIT Delhi and Masters in Computer Science from Birla Institute of Technology. His 10 plus years of experience with various fields of AI and ML, such as recommendation systems, LLM medical chatbots, large language models, neural machine translation, and data mining techniques would no doubt be invaluable for all the learning minds assembled here today. A very warm welcome to you, sir, and we look forward to hearing from you.
Uh, Hope I'm audible. Just confirm.
Yes, Mr. Satyajit, you are audible.
I'm sorry for being late. So, hope I'm visible. I don't know if my video is visible.
Yes.
So I don't know if I'm visible to you. So for just to start, I'm just switched on my video just to. I know the person who is talking, at least you understand who is the person who is the back of the, this PPT and all that. So I'm just stopping my video and let me present my PPT here. So is there any file section or something? I don't know. Share.
There will be a share option there. Yeah.
Put it in. Let me put it into slides share mode. Hope it is visible, right? Is it visible?
Yes.
Is there any other screen visible? There are two screens.
The single screen.
Single screen, okay. Let's see, there are two screens. Just give me a minute and just give it 2 minutes. Okay. So today's topic is all about natural language processing. I think in previous lectures, you people have done a lot of, this large language model I have seen starting from the first lecture. So you people have gone through all these large language models, the basic one. So today I'm just trying to touch up on natural language processing in context with large language model, because the large language model is something which is, it's a huge right now, a huge trend in the market, and also a lot of enterprises, they are using it. They are consuming as a service, LLM as a service. So it's very much important to understand apart from the natural language processing, because if you see the natural language processing under the huge umbrella, there is something called large language model. And also there is a concept of a small language model. So we will touch upon a few portions of this large language model as well as a small language model. Okay. So now coming to the second screen is visual. Second screen is not visible. My second screen.
No, you have only one screen with
now.
Now it's the second screen.
Okay,
yeah, second screen.
Okay. So coming to this NLP, so I will be trying to cover this NLP, generative AI and LLM, but I'll also show you some of the hands-on, because It's typically here in the sessions like this, you require some kind of hands-on also to understand the basic principles of this natural language processing as well as large language model, because there is a new concept called generative AI. There were something called a discriminative AI. Typically, it's a traditional AI where you typically learn different kind of a modeling. For example, logistic regression, simple linear regression, maybe support vector machine, decision tree, random forest. There are many more, right? So they are more of a discriminative AI, but when it comes to generative AI, typically it's more connected towards generating new content for you. Maybe it's a text generation, maybe it's video, audio. You just name it, you can generate a lot of a new content, which is possible, right? So we will be touching upon all these things in this lecture today. And obviously at the end of the session, I'll try to do some kind of hands-on so that you can understand how you can leverage this generative AI and large language model to understand how a new content is being generated, right? So coming to this AI area of research, if you see this, the visual, this picture here. So typically we go with this artificial intelligence, the definition part. So I will not be defining it, what is artificial intelligence, machine learning and deep learning. I'm just assuming you people know it, okay? So coming to this artificial intelligence and, there are a lot of, you can say the junctions between AI, data science, the natural language processing. Maybe there are some area called cognitive AI. There are many more areas, but don't get confused with all these terms, okay? So when it comes to artificial intelligence, if you see this on the left part, there is something called natural language processing. Here in this lecture, we are more concerned about this natural language processing, okay? So coming to this natural language processing, you see there are something called speech to text, text to speech. Okay, so these are the some area. There is something called translations. Okay, so there is a new term called neural machine translation. So whenever you try to convert from one language to another language, okay, typically you do some kind of a translation. So Google gives you a translation of, let's say, 100 such languages of the world, or maybe let's say 250 languages. But there are different languages which are their representation in digital world is very much less. It's a very you can say they are you can say their representation in digital world is very, very less. So digitally you can say their representation, there are many languages, their representation in digital world is, you cannot see their digital footprints. So how you're going to capture that? For example, there are languages which are dying, right? So it's not like your own language, for example, there are many people in India, their local language is different from Hindi. And also maybe the Punjabi, maybe the Gadwali, there are different languages, the Udia. May possible that there may be a language, the local language, which are, the frequent in use, but they are not digitally represented. Okay, so how using this, the natural language processing, artificial intelligence, you try to, save that endangered languages, the language which are not spoken and the languages which are not digitally represented, there are chances of being, endangered, or maybe they may extinct someday. So whenever a language die, a whole civilization die. So it's we are in an era of AI. So it's our duty to save those dying languages. So we should not let language die, right? So the language itself has a huge potential, huge cultural bindings, and they bring a lot of new ideas, right? So the AI can have those potential to bring things up for you. And also you can save a lot of culture civilizations around the world, right? There are many scriptures which are written in local language, and it's very difficult to decipher that. So how through this NLP, the machine translations, how you can generate a new content for them so that they can write a good novel in the local language, right? So these are some area you can work on, right? So coming to this natural language processing, I think I'm not interested in defining it, but I'm more interested in the application part of it. Okay. So for example, if you see in this slide, there is something called information retrieval. Yeah. Let's say you have a lot of documents. For example, let's say a lawyer has a lot of documents to read, and then they prepare some kind of reports, maybe some medical documents you have, and now you're trying to bring something out of that medical report, that what is the critical in the some patients. So the information retrieval is something that can help you out. And the large language model, there is something called the retrieval and augmented generation. It's a more of an information retrieval kind of a thing. Let's say you put in a book. Let's say it's 1,000-page book, and you're trying to query it that just give me the answer of these things. So once you put in the entire database, entire PDF to LLMs, they query it out for you and give you the relevant information for you, right? So it's called information retrieval. Then comes this sentiment analysis, okay? So sentiment analysis, if you go through it, you might have heard of a lot of sentiment analysis also in traditional AI. You might have used some kind of, let's say you pull out some data from the Twitter, and you try to see the kind of sentiment. For example, the recent election happened, and if you see on Twitter or any different social media, you'll see a lot of people have a different views about this government or the previous government, or you can say the previous party or something. So they have a different kind of the sentiment. So sentiment analysis gives you a pattern, right? For example, if a government rolled out some kind of beneficiary program, so what are the sentiments towards those beneficiary, the programs? So you can pull out those, the social media data, and you can do some kind of a descriptive analysis. So sentiment analysis is nothing but a more of a descriptive analysis, where you try to put in different themes. You try to extract different themes out of the different sentiments which you have extracted from in a different corpus. Okay. And there is something called information extraction. It's more of an information retrieval, and you try to extract some, the keywords, the key phrases out of a document or out of a sentence. Then there comes a machine translation. I have just explained you the kind of a machine translation. So you can also do some, the language which are not so popular, and their translation in English on different languages, so that the translation is required, so that you can kind of spread some kind of knowledge to one generation to other generation. That is also required. So machine translation is something can bridge between these kind of stuff. So you can pass on one knowledge to another generation through these kind of translations. And there comes the question answering. So question answering is nothing but, for example, you have books, or maybe you can define some kind of let's say 10, 12 books you have, and then out of that you put in some kind of a prompt. Okay. So these are the something you can design in a question answer, and also you can design in a different way, so that you can query it, you can prompt it to the systems, and then they give you the answers that is relevant for you. That is the crux of this kind of LLMs applications. Okay. So now coming to this, there are different, when you deep down. So in natural language processing, you have, NLG, that is, natural language generations. It comes more of, for example, discourse generations. Okay, for example, if you want to generate a dialogues, okay, document structuring, maybe the realization of something, and lexical choices. These are the some terms which are more of, you can say, okay, so you want to ask something, Madhvi? Yeah, Medhavi, sorry. She raised her hand, so how can I see what she is asking? Is there a moderator out there? Okay, it was by mistake. Okay, that's fine. Okay. So then there comes NLP, natural language processing. So you might have seen in your books, maybe if you've gone through it, there is something called named entity generations. For example, in a documents, or in maybe in sentence, maybe there are some names, the name of the places, maybe there might be the phone numbers. So these are some entity. So when you pass on some kind of the information, so NLP gives you in this name entity recognitions, you try to recognize what kind of entities are there. Then there comes a part of speech tagging, that is something called a POS. So in a sentence, there is a noun, verb, or adjective. So you try to understand it, that what kind of words are being spoken, whether it's a the only the nouns are there, or maybe the some kind of verbs are there, just to understand the semantics of any languages, or for that matter, for the English language here. Synthetic parsing, there is something called a parsing, conference resolutions, and machine. These are the some applications. So you just go and check all these things. So how NLP can help you out if you are working on any research project, or maybe some of the project, okay? Then there comes NLU, natural language understanding, okay? So natural language understanding is more of, you can say it's an interesting one, because here there comes the LLM part, it comes in the picture, okay? The sentiment analysis, topic classifications. For example, you just want to understand in a document, or for example, let's say the Prime Minister of, let's say, US is delivering a speech, and he had, let's say, 1 hour speech, and you're just trying to figure out what kind of topics, what topics he had more discussions about. Maybe he talked about the climate change, or maybe he talked about the the tourism, maybe he talked about the medical facilities. So what kind of a topic he discussed in that kind of the 1 hour lecture. So that can give you the sense of a topic classification. Then comes an information extraction. So the relevant information you can extract out of those, you can say, the 1 hour lecture of the Prime Ministers, the entity detections, it's more of a name entity recognition. Then there comes a summarization. For example, our MPs typically gives, let's say, the speech in a 0 hour, the sessions. So, so it's a duty. I mean, there are many, the programs where the what MPs, told in a 0 hour session. So you try to, in a summarizations, typically they give you the bullet points. So it's more of a summarization. So you can, if you, let's say, work on those kind of a project, so you can just transcribe their, the speech into the text, and then again text into the summarization format. There are many libraries in Python. You can do it for the summarization task, okay? Then semantic parsing, synthetic analysis, these are something which you can apply on depending on your research, okay? So the screen is freezed. Is my screen freezed on this page? Screen is freezed. Okay. Now it is moving. Can anybody confirm? Is it moving? Can anybody confirm? Okay. So try to interact so that I can understand, because it's like a black box for me. Okay. Thank you so much for telling me that my screen is moving, but it's freezing. Okay. Now. Okay. So it's more of a timeline of NLP. I mean, you can go through it. I'll share you this PPT. When it comes to 2010, okay, so there is something called word to vector, the rise of LSTM, encoder decoder techniques, attention and transformers, and pre-trained models. So the interest lies here. These all are the basics ones, but obviously the huge, you can say, success to this NLP. But when you see this 2010, this timeline here, so there are a lot of, the libraries, you can say, and a lot of models are there. So these are of our interest. So word to vectors. So obviously it's a more of, when you give any text to your machine, so it typically converts into some numbers. Okay. Then there comes LSTM, long short-term memories. So also used for text data and also for the time series data, and there is something called CNN. So during this 2010, there was a lot of advancement happened in NLP domain. Okay, then there comes the attention and transformer models. So in coming classes, you will get to know what is attention mechanism and transformer, what it typically does. It takes sequences of the data. Then there comes up pre-trained models and the transfer learning. So pre-trained models are nothing but typically when you see this chat GPT, what is that? It's a pre-trained model. They have a huge corpus trained on millions and billions of parameters. So whenever you give a prompt, they give you a desired response. Possibly not, sometime it hallucinates, gives you different results, may possible, and maybe it may not be relevant. So it's typically a black box. So any pre-trained models are typically black box unless and until you doesn't know the how it works. And there, the programming methods, or maybe you can say their mathematical logics, what they applied to build this pre-trained models. Okay. And then if you see the timeline of 2020, GPT-3 and large language model. Okay. So generative pre-trained models, GPT, typically it's the name suggests, and there is something called large language model. So obviously the OpenAI came up with this chat GPT, then this Google came up with the Bard, and now it's Gemini, right? So more of a language model. So because, the language, for example, like a human. So if you know, maybe if you are trained on the different situations, for example, and you have a lot of knowledge, for example, you have read a lot of books, if someone asks you, you typically give the answers, right? So same way, the machines are being trained on billions of parameters, on textual data, audio data, the image data, videos data, and they are feeding into, okay, the systems are being made in a such a way that you give a prompt and they give you the answers. Okay? So the rationale behind this large language model is obviously just to replace the human, the way human thinks, the human mimics. Okay. So now there are a few terms and terminology you must aware of. You must, because in NLP domains, in coming lectures, you might be, you might be taught this bag of words. Uh, then there is something called TF, IDF. These are the vectors, term frequency, and the reverse of that. The co-occurrence matrix, word to vec. There is a globe. These are some libraries. There is something called transformer models. So GPT is typically the large language model. Whatever you see, the pre-trained models are trained on these transformer models. The architectures are based on these transformer models. ELMO, BERT, and XLNet. These are some pre-trained models. So in coming lectures, I'll show you how you can leverage this BERT, XLNet, ELMO, all these things for your applications. There is something called downstreaming. So I'll explain it to you in lectures when when it comes to teach this BERT and XLNet. So now comes, there are a few basic terms. I'm just skipping this because this AI, ML, and NLP. These the pictures you might be aware of, and you typically consume all these kind of pictures nowadays, because you see a lot of research happenings around this large language model, and you come across these kind of pictures. Okay. So if you see this AI, there is also further, if you go in deep down to this natural language processing, you have a large language models, and in different large language model, you have also small language models, and that is trained on a few sort, the data. There is something called few sort, two sort, or something kind of, the algorithms. Okay. So now coming to this machine learning, they are typically defined on supervised and unsupervised. But the interest here is, I'm not explaining this regression classifications here. Obviously, if you go this regression gives you a single output, but classification gives you maybe the more than one. For example, a binary classification. For example, if someone has a COVID or not, can come under this classification. But my interest is unsupervised learning here because in context of large language model, so if you see this large language model, they are typically unsupervised because they are given a lot of data. If you go with this chat GPT only, they are trained on textual data, but now they are trained on also on the image and all that. But I'm sticking towards this textual data. So they are typically unsupervised. You don't know how they have stored it and what kind of algorithm they have used to give you the response, because you only give you only give LLMs the prompt. You just give ChatGPT a kind of a prompt, a kind of instructions to it. You pass it on and they give you the response. Possibly you get a different response. Maybe if you set their temperatures and all that. So these are something where a kind of some elements of hallucinations comes in. But the more my stress is on this unsupervised learning, because the rise of these LLMs lies on these unsupervised principles. Okay, so if you see this unsupervised one, supervised, the data has obviously the training, and there is something called a label. So the features and targets are there in your supervised learning data sets. Okay, so data has a label. Okay, so for example, a Coke bottles, it looks like a red, but it doesn't have a label. How you're going to identify it? If I put a label to it, for example, it's written Coca-Cola, right? So that you can easily identify it's a Coca-Cola, right? That is, there is a label to it. So the supervised learning, if you see their data set, they are more of, obviously they do have a labels. If they don't have a labels, it will fall under unsupervised learning. Okay. So how LLMs generate, what you say, the response for you, right? So the response, the being generated through this LLMs, they are more of a probabilistic based. So there is one algorithm called a naive-Bayes algorithm. So the base of this LLM somehow relate to this naive-Bayes algorithms. But if you see their data, they are obviously unlabeled. They do have a labeled data, but you can say the proportion of the data are unlabeled. For example, you just want to apply ChatGPT to give labels. For example, your university has given you one task to annotate the, you can say the financial news. They have given you, let's say, a corpus, or they have just asked you to annotate the financial news. Annotation is nothing but it's like a classification, putting labels to it. For example, a Sensex is going to rise. So whether it's a positive news or negative news, for example, the recent election happened and now maybe the Sensex are going up or down, I don't know. So based on the news, you just put a label that, oh, okay, this one is a negative, this will fall, this news is negative one. So you can leverage this chat GPT also to put labels. Okay, so labeling is being considered, and you can say it comes under unsupervised when it comes to chat GPT, because you are just giving a prompt. You are saying just put labels. I'm just giving you a news. So you have given a news of, let's say, 2 lines to the chat GPT, and the chat GPT is giving you the labels, maybe the positive, negative, or neutrals. Okay, so this comes under unsupervised learning because you are giving a data which are not annotated, and you are telling chat GPT to annotate it just to put a classifications. Okay, so this comes under unsupervised. Okay, so these are the some applications of chat GPT. There are many more applications of chat GPT. Okay, so now comes a concept of discriminative and generative. Okay, so which I have talked on. I mean the discriminative ML and generative, the ML. You can say generative AI. So also you call it a discriminative AI, right? So in discriminative AI, typically it's used to classify or predict. For example, you just want to classify it that who gonna win. I mean, in the next election. So you're just classifying it. Maybe if someone has, let's say, I'm just giving you example, has someone has COVID or not. So you are classifying it. Okay. So for example, you're gonna pass some exam or not. Passing and failing is the two class. You are just classifying it. Okay. So discriminative has a, in this kind of learning, you try to classify it, typically trained on a data set of a labeled data, right? Because your data, if your data is labeled, then only you can train a systems, then only you can train a ML models, right? So discriminative works on a trained data set. Okay, for example, uh, during the COVID, they used to capture a lot of parameters, whether you have high fever or not. What is your test? Whether when you eat, what kind of test comes in, right? So maybe there are many parameters. Can't recall it, but and then they used to put the labels. Okay, he has the COVID at the end, right? So these are some examples of a labeled data, and if your data is labeled, then you learn a relationship between the features and the target variables. Target variables is nothing but it's a labeled data, right? Then there comes a concept of a generative AI, and it's a talk of the town. Generates a new data that is similar to the data it was trained on. For example, I'm just given a prompt to ChatGPT, and I'm saying, so just define it. What is generative AI? So they give you the answers in a long paragraphs. Now you want to stick to like, okay, fine, just give it into 100 words. So they give you in 100 words. Okay. So because the data they are being fed is similar to the prompt you are asking. It's not like you are asking what is generative AI and they are giving you how, what is the price of mango. It is not going to happen, right? So, and also generative AI understand the distribution of data and how likely a given example. Obviously, as I already told you, the new content being generated through LLMs, they understand the distributions of the data which are trained on. Okay, so the based on the distributions of the data, they give you the answers when you give the prompt to it. Okay, and also it predict the next word in a sequence. For example, if I'm saying I'm traveling to, so they're gonna fill it. What next gonna come? So let's say I love Delhi, right? So if I say I love and then I'm just putting a blank, they're gonna put a Delhi, right? So let's say I love eating mango or something. So these are the some words in the next sequence, they're gonna predict it based on the previous distributions. So how your previous sentences are being framed. So every sentences has some kind of a distributions. So the LLMs typically or chat GPT, they typically captures it, they store it, and whenever you give a prompt, they jump onto the answers. Yeah, so this is how your chat GPT or large language model typically works. So if you see these examples, I mean, how this generative AI and discriminative AI looks like, right? So generative AI works on the new distributions. If you see in the left side, there are the distributions. So it's more of a clustering kind of a thing. It's more of a unstructured. So that is why they put a labels because it was unstructured. And then it is saying it's a dogs, it will fall under dogs. And now these circles gonna fall under cats and cats, right? So what they typically does is the systems has been fed, the unsupervised data, and then based on the distributions, they club it together and they put a themes. Now these themes are under the dogs and these themes comes under the cats, right? And when you go on the right side, now on the right side, it is saying that whether it's a cat or dog. So it's a classification problem. So maybe it's a regression problem, but right now it's a classification problem. So how you're going to classify it? For example, now based on the training data, you classified it because these points fall under cat and these falls under, let's say, these red bubbles falls under cat and the blue ones falls under the dog, right? But when a new data comes in, unseen data to the AI models which you train on, so how they're gonna fall, where they're gonna fall. So the based on these lines, these discriminative lines, if their distributions lies here, so it will ultimately say it's a dog. Otherwise, it will say it's a cat. Okay. So this is how generative and discriminative models works. Typically, the generative ones works on the the distributions of the data, and the discriminative works on the you can say a kind of a classification required, a threshold required to separate the two labels, because here are the two labels, one is cat and one is dog, right? So how they separate it is the task of discriminative, but the distributions on unsupervised data falls under the generative AI concept. Okay. So when you see this predictive model, so typically in traditional AI ML, if you see, you typically provide data and the label to the models, and then they gives you the output. This is nothing but it's a label ultimately. Okay? For example, the systems, for example, you just want to predict whether someone will get a loan or not. So you will pass in some features. You will, data is nothing but it's a features. You're gonna pass. Let's say you're gonna pass some features to the model. Let's say age, their salary, maybe how much do they carry some kind of a credit card, maybe their educations, where they live, and maybe they have a different, the saving accounts or not. So maybe there are many parameters. So these are the features, let's say 12 features you have captured, and labels is nothing but labels you put in that, okay, yeah, this guy should be given the loan. Or maybe historically, this guy have been given a loan. So this is your data and the labels, you put systems to it. And then let's say a new, new customers comes in, and obviously a new customer will not have the labels, so you will only capture their features, age, educations, whatever I told you, that let's say 12 features you have collected, and 13 features is the labels that you want to predict it. So once your model is trained on, you just pass it on to all the 12 features and you will get the labels, right? So this typically the works of traditional ML model. Okay, but when it comes to generative AI, just see the unstructured content is being given to the model as an input. So the entire generative AI models are trained on unstructured content. It's like giving a lot of uh, huge you can say the huge text of a data, if you consider it the text LLMs. So you are giving oceans of a data to the models, and then they give you a new content for you. It's like a teaching students, let's say 1,000 books, and then you are asking some questions, right? So this is more of a generative AI concept. Okay. So now coming to this generative AI, I mean, obviously, if you go the definitions, I mean, though you may see different definitions here. So, but here I have written that techniques that learn from a data about the existing artifacts and use this to generate a new artifacts. Okay, a more of a new content. Okay. So there are some foundations models, and there is some large language models, and now you have a chat GPT. So the chat GPT typically it was developed by OpenAI, and obviously it's more of a chatbot, and they typically creates the new content. Okay, so when you see a new content, when I see a new content, so new content means uh, the based on the context. So whenever you pass a prompt to the systems, a prompt to the chat GPT, it should not be like anything you are asking. It must be some context to it, because chat GPT also understands some context. Okay, you cannot ask any questions if you are asking any open-ended questions, so they're gonna give you open-ended answers. So if you are specific to it, that is why there are a concept called a prompt design and prompt engineering. In coming classes, you will get to know how you can design a good prompt, because a good prompt will give you the good response. Ultimately, our aim is to get a new content, but it should be contextually aware, whether it's fulfilling our context or not. That is the meaning of generative AI applications uses. Yes. So, generative AI, I mean, the definitions, as I already told you, there are many applications of generative AI. But I mean, if you see some kind of, the audio models, maybe the video models, then how they're being trained on. For example, maybe you just want application to be built based on the voices. Okay, so voice applications, how you're going to create such kind of LLMs. So obviously you're gonna capture the voices of a different people, right? So maybe let's say you have a captured the voices of, let's say, 1 lakh of people, or maybe a million of people. Let's say some theft happened, and based on the voices you just want to capture their identity, which this person is. So in the coming, maybe then the coming the years, you'll get to know these kind of applications. You just pass into the voice and they give you the entire details. So that can be the possible things that can happen, right? So coming to this, I'm just giving you a 5 minute break. Will it work? Is there coordinator out there? Coordinator is there or not?
Yes, we can have a 5 minutes break. And in the
Uh,
meantime, students, please mark your attendances.
and if
And
you have any questions, you can ask also. And okay.
in
So
the
I'll
meantime,
I'll
if you
come
have
back.
any doubts, you can ask questions.
I'll come back by 5:15. Audible? Hello, am I audible? Okay, so
Yes, yes.
okay, so let me start. So why generative AI is so popular? Because there are many you can say the models which were typically there. Let's say CNN was there. It's a more of you can say convolution neural network for the images and all. And then comes there is something called LSTM, okay, long short-term memories, the RNNs, because their frameworks works on the RNN only. So in place of the CNN, RNN, and LSTM, why we typically require this generative AI concept? Okay, so but there are problems in these kind of models. And for example, CNN are good at local feature extractions, but when it comes to understand the long range, dependency in an image, then it struggles. CNN do not have a mechanism to understand the ordering of the elements in image data. Okay, maybe also if you're using a text or time series data, that creates a problem. So there are many challenges which typically had with these traditional, the models. So that is why the concept of this generative AI, because generative AI is eliminating the all the problems which you typically see with the CNNs, RNNs, and LSTMs. Okay, so that is why this concept of generative AI is creating, a lot of attention in the market, right? So, so the generative AI, you have as one of the research paper called "Attention is All You Need." Just go through this research paper. It talks about the transformer models. Okay, so more of the all the GPTs. If you see the large language models, their base works on this transformers only. Their architectures lies in this transformation. The transformer, the concept of transformer only. Okay, because the transformer models, it typically takes the data in sequential manner. Sequentially, they understand the data and then they encode it and store it. Okay, that is why this generative AI concepts works very well. Okay? And all the GPTs you see has a base concept of these transformers. They require this kind of attention mechanism. Okay. So in coming lectures, you'll see how attention mechanism works. You will go through this Python programming also to see uh, how to leverage this attention mechanism and how to solve the problems. Okay. So generative models, if you see this one, you all aware of it. So I'm just skipping it. So coming to this, deep learning and this classical NLP, if you see what kind of a problem you are solving it. Okay. For example, sentiment analysis, classification, entity extractions, translations, and topic modeling. Okay. So you can solve these kind of problems through the traditional model also. For example, in pre-processing, if you have a textual data, you do some kind of a tokenizations. Okay, and then you do modeling feature extractions. Ultimately, once you extracted the features out of the model, your 80% of work is done because it gives you a pattern. So, but why you require deep learning kind of a thing? So because in deep learning, what typically happens is they add some layers, that is hidden layers. Okay? So hidden layer is more of a kind of, you can say, the black box. You don't know what kind of things happening inside the black box. So if you see the blue ones, these green ones here, these are nothing but a hidden layer. So once you pass the raw data, they do some kind of embeddings corresponding to your textual data. and then they put in a hidden layer. They do some kind of a mathematical calculation, and then they comes up with the analysis. For example, you are applying this model for sentiment analysis only. Okay. So when you pass textual data, they pre-process it, they train the models, and they did some kind of a calculation in this hidden layers. So hidden layers makes the ML models a bit faster. It learns a lot of patterns, the hidden patterns inside it. Okay, so these deep learning models give you more advantage if you have a huge data. So dense embeddings, when it comes to dense embeddings, it's like, for example, word embeddings. Okay, so every words are embedded. For example, let's say there is a word called king and queen. Okay, so king is related to queen. So king has been given some weight, let's say 001, and queen is given a weight of 002. So they are the similar words opposite to it. So when a question comes in, so how you are going to pair it to king to queen, similarly with male to female. So dense embedding is more of giving weightage to the words and also the sentence when it comes to transformer models, because they understand the left and right sequence, okay, the context of it. So it happens in a dense embedding layers. Okay. So you also do some kind of, apart from sentiment analysis, you do some kind of a classification, entity extractions, which I am talking about. But in coming, the classes, you'll get to know how you're going to apply sentiment analysis through the Python programming, entity extraction, translation, topic, and all these things. Okay. But you must aware of these words, the umbrella of natural language processing and their applications. Okay, and also in the industry, how they are using this, the NLP techniques, and on what purpose, and why they are applying it. Okay, so some applications, and there are many more applications when it comes to the generative AI. Okay, so now comes this ML model versus large language model. So obviously in machine learning model, if you see in the left side, you have algorithms. Algorithm is nothing but you have machine learning. You can say uh, algorithms is it's like, for example, if you are applying, let's say, support vector machine. Just give me a minute. Just give me a minute. So when it comes to an ML model, if you see the data and you have some algorithm, for example, if you're applying support vector machine, okay, so what kind of data you're going to pass it? So data labels, data should be labels. For example, the email which you received, whether it's a spam or not. So this is a label data. You train it to some algorithms, let's say support vector machine. And when a new data comes in, then you predict it, whether it's a spam or not. It comes under machine learning model. Then comes large language model. So how they works? So typically what you do when it comes to, test it. So you give some kind of a prompt. Prompt is nothing but it's just instructions, which are more of a context driven, right? You give a prompt. And but there is something called a pre-trained model. So you do not need to train the model. Like in ML models, you have to gather a lot of, the data, extract a lot of data. You just fine tune it and you just train the model and then you predict something. But in large language model, it doesn't require it because the model is already trained. For example, GPT-3, Generative Pre-trained Model 3, GPT-4, they do not require any kind of a training. They are already trained. Just what you have, just what you require, you just require a good quality of a prompt, right? So once you give a prompt, instructions to Chat GPT slash LLMs, they give you the answers. For example, if I pass an entire email to this Chat GPT, and if I tell them whether it's a spam or not, they give you the answers. How they're going to give you the answers? Because they are already trained on some kind of a text data which are related to this spam and not a spam. That is why they are giving you. So large language model just eliminate the concept of a pre-training, because the model is, it's like already cooked food. Now just you have to eat it, right? So LLMs are nothing but it's a cooked food for you. You don't require any kind of a chef. You don't require any kind of a, a maid. Just only require the prompt. It's like just go and eat whatever you want to eat from your kitchen. Okay, so it's a LLM. Okay? My screen is again freezed 1 minute. Okay. Now comes the large language model. We are discussing it since these LLMs. So in large language model can be, it can be more complex. Maybe they do have some n-grams models. There's something called bigrams, n-grams, that bigram, trigrams, n-grams models. To more sophisticated neural networks models, the term large language model usually refers to the models that use deep learning. So I'm stressing the word deep learning techniques. So every LLMs, large language model, there you can say backbone lies on deep learning model concept. They use some kind of a hidden layers. Okay. So they are trained on millions and billions of parameters, because when you fine tune any models, okay, they give you the answers, obviously they eliminate a lot of type 1 and type 2 errors. That is why you just try to do some kind of a hyperparameter tunings. The people who are aware of this hyperparameter tunings, they get to know that why you require this kind of hyperparameter tuning. But you do not do more tweaking. It's like a tweaking a model, tweaking a training data, right? You cannot tweak it. What I have to explain, Sonia? Can you write it again and the questions so that I can explain it for you? Just write a questions. LLMs, okay. LLMs in simple terms, if I go with a kitchen concept, for example, everybody has to, obviously, let's say you are how we give an example, LLMs. For example, we typically cook, right? Okay, LLM based on NLP. What I understood your questions, LLMs based on NLP. Obviously, LLMs are based on natural language processing, the concept of natural language processing. So the language, when you say a language and when you say a natural language, so right now what I'm speaking is a natural language, right? But the language sometimes being spoken by the computers also, right? So the natural language processing, the humans when they speak, because there are different, when it comes to language, maybe the audio, text, video, all comes under the input to the language. It's not like only the audio which I'm speaking right now. Maybe you can transcribe my entire lecture and you can, it will give you some kind of a text, maybe let's say 1,000 words text, and you give it to some system. You can design a systems and you can find it out that what kind of words I have spoken, what topics I have spoken, and what kind of examples I have given you, right? And what was the subject of the entire session. So LLMs are nothing but it's a large language models, and it comes under the natural language processing only. Okay, and they are already pre-trained. You don't require any kind of a training. You don't require any kind of a gathering of data, but you can fine tune based on your applications. For example, you just want to summarize a document. Then you have to fine tune some of the pre-trained model. There is a platform called Hugging Face. So Hugging Face is a platform that gives you a lot of pre-trained models. So based on that, you can fine tune the models. So now coming to this generic language model, for example, in generic model, let's say you just want to predict a next word. Okay? So next word like the cat sat on. The cat sat on where? Okay, so possibly the cat sat on might possible the next word would be the, most likely next word. Possibly the next word might be the AR. Next word, okay? And there are many words in a sequence that may appear, but they are less likely to happen as a next word. Right? So these are the sequence. So typically LLMs, what they do, they understand the semantics, syntactics, and context of a sentence first, and they store it. So once they store it in a vector form, they try to predict the next word. So whenever you give a prompt to Chat GPT, they, they give you answers. It's like writing on a board in a real time, right? So how they give you answers in a fraction of seconds? Because they try to predict a next word based on the previous distributions. Okay, so this is how your LLM works. Okay? Now coming to this, the few you can say the important features of these large language models. I mean, obviously they are trained on large data set. They must have a huge corpus inside that. Corpus is right now I'm referring corpus as a textual data. I'm keeping LLMs as a chat GPT only because there are many LLMs. You can give let's say audio data. Maybe you give some pictures to LLMs. For example, if someone has a pneumonia or not, and you are giving X-rays to Gemini model, let's say. So if you give X-ray to Gemini models, they're gonna give you whether this X-ray has some kind of pneumonia or any other disease if you're giving some prompts. Okay. So okay. So is there some questions in the chat box? Let me take. So I have already taken these LLMs based on NLP, yes, and simpler terms I have explained it to Sonia. So, okay, if you have any questions, so okay, so what is vanishing gradients? Which when you mention LSTM, okay, so vanishing gradients, it's like when your model doesn't learn, right? So it's more of a vanishing gradient. Gradient is more of the learning happens in the gradients part only. So vanishing gradients will give you some kind of a no learning zone. They land you there. Okay, so it's a problem with LSTM, the vanishing gradient. Okay, so is there any more questions? So okay, so now comes this large language models. There are some features with this large language models. So let's say uh, they are trained on a huge corpus. It's a true, but the point is it's not like a huge corpus. I mean, whether it's a the prompt which are giving is a contextually giving you the answers contextually right or not. That is a more important, and they are already pre-trained. Obviously, pre-training means doesn't require any kind of pre-training, and it's like a commonality of human languages because the answers which you typically get is more of a you know you can say it resembles with the humans. Okay, so some features are here with the LLMs, and there are problems with LLMs also. Okay, so yeah. So LLMs and traditional, these models. So if you see with the traditional machine learning models, So they require some kind of a training. Also, you need to capture data for the training of ML models. And when you train a model, obviously, when you deploy it, you require some kind of hardware, right? And computational time, because you have to fine tune the model on different hyperparameters. And also you have to think of this uh, minimizing the loss functions. The questions is being asked about the LSTMs, because obviously you just try to minimize the loss functions, because the learning will happen more if you minimize the loss. Okay. So the model can only generalize it. But when it comes to LSTM and it faces a problem of vanishing gradient, they do not generalize the model, because once you put a training data to LSTM model, and if it faces the vanishing gradient, they are not going to generalize the model. They do not understand the pattern, the data on being trained on, right? So here it's minimizing a loss functions, means when you minimize the loss functions, your model is gonna generalize it in a more sophisticated manner. So whenever you give a test data or unseen data, then it gives you a more refined answers. Okay? But in LLMs, you do not require any kind of a training, pre-training. And also the people who are working on LLMs, they do not need to be more expert in the machine learning domain, right? Because it's already cooked food for you. Just you need to eat it, right? So yeah. So benefits. What are the benefits of using this large language model? I mean, because the large language model can give you, it can serve the purpose of different tasks. For example, you just want to summarize it, a document, a huge chunk of a documents. Maybe you just want to create a good story for you. You just want to create a good post. You just want to put something on a social media. You don't know how to write it. Sometimes, it gives you a starting point to think of. For example, I come across some kind of a research, but I don't know how to start, because a lot of people, in the PhD, they struggle with. So it gives you a chat GPT or maybe the LLMs models. They give you a starting point to think. With the earlier days, people used to go through the different research paper, right? Maybe you typically read 10 to 15, maybe the 100 research paper, and then you come across some kind of, the resource. But when it comes to LLMs, you put in your ideas that I want this kind of answers, or this is my research. They give you a lot of references for you, so that at least they eliminated your time of searching different books, physical books and all, right? So it can serve the purpose of different tasks at the same times. But if the LLMs are more beneficiary. And second one is fine-tune process requires minimal field data. So whenever you fine-tune the models, you do not require more of the training data at that time. Just a minimum amount of training and also for the testing data I require to fine-tune the models. Okay. And the performance is continuously growing with the more data. Obviously, LLMs, for example, right now, fine-tuning means, for example, uh, you just want to fine tune means, for example, you are using any models, pre-trained models. For example, Hugging Face is a platform where you have a different pre-trained models. You just want to fine tune it based on the application. For example, there is something called downstreaming. Okay. For example, you just want to summarize the documents, or maybe you just want to find out the sentiment. You just want to apply sentiment analysis, and your task is to use the pre-trained model. So how you're going to do that? So you just do some kind of a fine tuning based on your task or requirement. Okay. So if you fine tune the models, if you set some parameters on the pre-trained models, they give you the desired output. So that is why the fine tuning of a model is required. For example, uh, in Delhi, you have a different radio stations. So what you do typically, so sometimes 92.5 and 92.1, there are two stations, for example. So when you fine tune it, then the sounds or maybe the musics you get here is more, it's like a soothing or it's like a clear, right? So depending on your requirements, you just try to fine tune it so that your purpose is being solved. So this is the fine tune. Okay? And as the model has, LLMs are not mature model, but obviously when you put, the billions or millions of textual data, I mean, maybe data could be anything. So it continuously grows, it continuously mature. The way people get mature, because when you come across different situations, different kind of the behavior or okay, what is the difference between GPT and LLMs? The applications, you can say one of the applications of a large language model is Chat GPT. GPT is nothing but it's a generative pre-trained transformer models. So the basic backbone of any LLMs are GPT only, generative pre-trained transformer. Okay. So it's you can say it's a more of a synchronized one. It's not a completely two different things, but large LLMs are, you can say the umbrella, and inside that there is something called a GPT. Okay? So coming to this prompt design and engineering, so these are the two area which is booming. There is something called the prompt design and prompt engineering, because now you have a different LLMs. So prompt involves instructions and context passed to a language model to achieve a desired task. For example, you just want to summarize a document. So what kind of a prompts you are going to give it to LLMs? For example, the chat GPT, it should be context driven. It should not be like you are asking something different, but it's not contextually, the relevant. It should be relevant, but in context. But prompt engineering is, it's a more of a optimizing prompts, okay, on a variety of, it's like a fine tuning of model, more of a, if you go with this prompt engineering, how you optimize a model so that it gives you less error. And the responses you typically get is more of, of your, it matches with your desired, the outcome. So it's a prompt design and prompt engineering is the difference. And also a lot of hirings happens in this prompt engineering and prompt design nowadays. So the prompting, obviously the quality of input determines the quality of output. So it's like how you give an input. For example, if you put a garbage to any systems, it will give you a garbage out. So it depends on how you are designing a prompt, right? Summarizing a text of X. Let's say you want to summarize a X amount of documents. So also how you give a prompt, generate a poem in a style of, let's say, X. X means maybe some poets. Give me a list of keywords based on a semantic similarity for, let's say, document X. So these are some prompting you give it to Chat GPT, to the large model. Here, large language model is nothing but you can give it as a Chat GPT and they give you the answers, summarizations, writing, keywords. These are the some applications and how you give the prompt, right? So when it comes to applications, so you have different. Earlier it was a Google Bard. Now also there is the Bard is being replaced by the Gemini model, and obviously OpenAI, they come up with this Chat GPT, and now they have a Chat GPT 4.0, 4.0, 4.5, whatever. Okay. So they give you a capability of reading a PDF, also image. So you can query, you can put an image, documents, and everything. Are prompts still given to existing GPT or they were just given initially? I mean, your question is, I mean, let me see it, what you're trying to say. Okay. Are prompt still given to existing? Just Are prompt still given to existing LLMs? They were just given. Are prompts still given to existing LLMs? They were just given. Prompts are it's like whenever you train any. For example, I'll teach you how to this data set, custom data set to Hugging Face, and how you can create your own LLMs, or you can say your own GPTs kind of models. So what happens is, the prompts are, it's not like the prompts are not there inside the LLMs. Okay, it's there somehow. That is why whenever you give instructions to the models, they give you the desired response. Why? Because it is already there in a different format, the way they design the data set. Okay? So it is there, but when you give a prompt in a different way, they understand the context. That is why they give you the answers. Okay? So, so there is also some applications of the question answering in natural language processing. So there are different applications. Okay, so apart from summarizations and apart from sentiment analysis, question answering, machine translations, maybe new content, all are the new content generation. So for example, some company wants to generate a new content, their advertisement company, and they just want to create a new content for advertisement, new pamphlet where they just want to write some taglines. Maybe they want to do some kind of, on the social media, they just want to write some, maybe the 10 lines of maybe the paragraph or something, and they do not have an idea. If they put in the entire idea, they give you a new content, right? So the content generation it's like the gold mining kind of a thing. So the LLMs, it's a huge hit in the market, and it is still relevant, and it will be relevant, because the relevancy of these LLMs is because the different industries are using it. It's like a things happening in front of you. It's not like a future trend. Okay. So when it comes to this applications, and I think Santanu sir has given answers. So thank you, Santanu sir. So obviously your answers enrich us and also teach us a lot. So thank you so much, sir. So, and in this pre-trained models, and my concern is, it's not like a LLMs and their open AI. You can use it with better codings. But I'll do one thing. I'll take another lecture in coming days, and on that day I'll show you some of the the applications and coding part. Okay, so I think that can help you out, because on that day I'll show you more the codings and different pre-trained models. Okay. Which week of internship? Let's maybe in the coming weeks. I'll show you, because you must be aware of the few topics, the basic of NLPs and all that. Then some of the BERT, there are different BERT models, BERT, T5, BART models, and pre-trained models, GPTs. And there are different summarizations models, which I can remember is SUMMY, and there is one more. There is something called KL. There are different algorithms in summarizations, new content generations, and maybe the question answerings. So there are many more. Okay, so once you cover it, then we will start the coding. But possibly in the coming weeks, you'll get to know all these things, because the Python programming requires few more initial classes. Then you all will be on that same the level. Then we will start. Okay. So if you have any questions, it's open for you. You can ask questions related with LLMs, chat GPT or anything which you want to ask, or even the basic NLP. And if you have any query, you can ask. I'm just seeing in the chat if you have any query. Okay? So if you have any questions, you can ask. We can train our models via prompts. Via prompts, what you're gonna say via prompts, okay? So in Hugging Face, typically what happens is you have a different pre-trained models. For example, you just want to create your own models that is based on question answering. Okay? So custom question answering model you just want to create. So if anybody gives some general knowledge questions, so they give you the answers. So you can train a models. You can say the prompts, but it's more of a fine tuning a model. You just train it on, so you can understand it like that. Maybe the term and terminology is different, but you can fine tune it and you can customize your own model, create your own model. Okay, Kathy. Just write a questions and I can answer you. If you have any basic questions, LLMs, chat, anything you just want to ask, you can. Okay, so I think let's close the session. Santosh, are you there, sir? Yeah, Santosh, are you there? So, okay, and let's close the session. I think if you have any query, you can drop in here in a message. Otherwise, let's close for day. And next session, I'll show you how to do, how to apply these models, pre-trained models, and how to create some custom models. Okay, so that can help you. Okay. Thank you so much. Everyone, and I think I'm just leaving out. So thank you so much, everyone.
Yeah, if I'm audible, then thank you, Mr. Satyajit. You have, I think, covered a spectacular part of the curriculum. And students, some of you are bothered that whether when the coding and other parts will start. See, there depends upon the classes what we are covering. Once we'll start working on the generative models, once we start working on building of how to build the corpus, how to work on generative models, then in the subsequent classes, probably by next week, we'll start start coding. So we'll start it with a very simple form, like from the basics. So those who are not into extreme programming, they will be able to understand it also. So that's all for today. Thank you. Thank you, Mr. Satyajit, as well as students. Yes, we have created the Google Drive, and today I think by tonight we'll upload all the materials. Don't worry about it. Gunjan will get all this. Thank you.